cockpit of an aircraft is a very busy place, especially when you're flying at low altitude, the 400-foot range, 200-foot range. Your head's on a swivel. You're maybe looking in at your instruments, and I think a colonel in National NTSB, National Transportation Safety Board hearing had said, "Hey, we look in the cockpit about once every 10 seconds." So
Wow.
most of the time you're looking out for traffic. So now, while it's great to have a little scope that tells you that there's traffic in different places, the pilot is appropriately not going to spend a whole lot of time staring at that thing.
Right.
So now you go to the next level of safety, and that's where our true focus is. We can run the little background thing now as an image on that for ACAS.
Oh, there we go.
The image you see, super crowded. I think that was a NASA/FAA image, so all rights go to NASA on that or something like that. But basically, ACAS X. So ACAS, Airborne Collision Avoidance Systems. ACAS X is this current generation of that, and it's for whole airspace. And what that
Can I ask you a question?
Yeah.
Is this like the next generation of TCAS?
It's exactly that, right? So it's eliminate a lot of the restrictions that were on the use of TCAS, and I'll explain that in a second.
Okay.
So now you have ACAS X, and ACAS X has a whole bunch of little ways to differentiate which version of ACAS X. So TCAS was TCAS. You had TCAS 1, and then TCAS 2 did certain functions. They weren't for different aircraft that had new capability, right? And then along comes ACAS X. Some of the limitations.
I'm sorry, I'm going to interrupt you.
No, go ahead. That's right.
Terrain collision and avoidance system. That's what TCAS.
Not terrain, traffic.
Traffic. Sorry, traffic collision and avoidance system. So what's ACAS?
ACAS is Airborne Collision Avoidance System. So yeah, don't get me into that. I mean, because truthfully, with TCAS, Europe called it ACAS, and now we come along with a new ACAS. But now everybody, I think, is around with ACAS X as the most modern technology because there's a few things. So TCAS limits the aircraft that it's applicable to. So TCAS was designed for commercial aircraft. It was started after two commercial transport aircraft, airliners, crashed over the Grand Canyon in 1947. And that was when that technology was started to develop, right?
Yep.
And so it requires that you can climb at a certain rate, 2,500 feet per minute. It requires that your aircraft is moving at greater than 100 knots to be effective, or something like that, right? So it's pretty restrictive. Well, an eVTOL aircraft.
You alluded to this, but with the ADS-B, you have to look at a screen. With TCAS, it kind of yells at you.
It does yell at you. There's oral alerts, right? And then there's also alerts in your cockpit that tells you you have a traffic advisory that says there's traffic at a certain place. It might say traffic. And then there's a resolution advisory. And in theory, the traffic advisory is advisory in nature. You've got traffic. And then the resolution advisory is directive in nature that tells that you must follow, right? If you have that installed,
climb or
climb or descend, and that's all it says on TCAS. So TCAS, and when the two aircraft have transponders that are talking to each other, they do this little magic of putting different information in different registers. So one will climb and one will descend to avoid a collision, but it's always vertical advisories, climbing and descending to avoid potential collisions.
So how is ACAS, how does it improve on that?
So ACAS improves in a bunch of different dimensions. ACAS is better. And it was developed by people that develop things that I can barely pronounce, right? But these Markovian processes, it's probabilistic. It uses machine learning in developing the algorithms. But a couple of things. So the ACAS X has a bunch of variants. There's ACAS XA, which essentially is the next version of TCAS 2. There's ACAS XO for different unique operations, like two aircraft landing on parallel runways. You don't want to have them trying to avoid each other and miss the runways. Okay. You've got ACAS XU, which is for larger fixed wing drones, like Reapers and things like that, right? Okay. You've got ACAS SXU, which is for small drones, rotary or fixed wing. And that's passive. So that's for the kind of quote below 55 pound, and there's sort of a gray line is 55 pounds, but that's roughly where the cutoff is. And then you've got ACAS XR, which is for rotorcraft. And interestingly for us, we're focused on that right now because this will be the first time that rotorcraft have a collision avoidance system that is relevant for a rotorcraft, right? Because
Wow.
the case
That's
no, so
kind
that's
of crazy to me.
yeah. So the one so that's one thing. It's applicability to all different aircraft that are going to be darkening the skies, right? That's one advantage that ACAS X brings. There's a few others. There's the potential to reduce the restrictions on altitude. So TCAS, and again, don't quote me on this because I don't study TCAS because we're not making it, but I think it's about 1,000 feet below that. Resolution advisories are suppressed or something like that.
Oh, yeah.
So once you get in,
Yeah.
once you're coming in, then some of your alerting is repressed. And this instance that we talked about around National Airport was at low altitude. So those they would have had suppressed alerting in that place. ACAS allows the system to operate at a lower altitude. It also reduces more than 50% of the quote nuisance alerts, right? So there are times with TCAS when it's telling you either that you've got a traffic or potentially a resolution that are not valid. They're false positives, right? You're not on a collision course with that aircraft for a variety of different reasons. And ACAS, the way the algorithm has been developed, is much better at filtering out false or nuisance alerts. So greater than 50%. So those are the primary reasons that ACAS is an evolution of TCAS, a better evolution, right? The applicability across different aircraft. Oh, and it also gives you not just climb and descend alerting, which obviously at low altitude, a descend alert would be a problem.
Yeah.
It can give you turn left and turn right alerts. So it can give you horizontal or vertical guidance or blended. So it might tell you turn right and climb or turn left and descend or things like that.